is real-time spatial data feeds. As you might be aware of, Esri is the manufacturer of geographic information systems, and typically most of the features we are dealing with are not very dynamic so far. But that is actually something that is changing very fast now, and we see more and more sensors popping up, and we actually are interested in what's the current status of an object or a person is actually. So we are deviating from a very static approach to a very dynamic approach. If I talk about sensors, it could actually be anything. To give you a couple of examples, you might think about persons, people of interest, right? They are moving around, and you might wonder if they are close by, if they are far away, if they have lost path, things like that. If they are entering danger zones. Another type of sensors could be home automation. More and more people tend to make their home intelligent in the sense of they equip their home with, for example, sensors that read out the heating, temperature, solar panels, how much energy do I consume, how much do I sell again with my solar panels, things like that. Right? Then another example are obviously all the social media. I mean, it's just not countable anymore how much data is produced there. And you might wonder why I'm mentioning that, but actually, if you give it a thought, this is super powerful. I think they already have proved that with Twitter, for example, there's not a single early warning system for earthquakes, for example, that is as fast as Twitter. Right? So yes, that is a very valuable data source, and you might want to use it if you are developing early warning systems for earthquakes. Another good example is, of course, RSS. We have environmental sensors that measure, for example, the levels of rivers. Do they exceed a certain threshold? Then yes, we do have flooding, or at least we have a certain probability for that. Traffic, yeah, that is your business. And so forth and so forth. So there are millions of sensors, and the challenge for us is actually to make them digestible, to actually make them manageable, readable, digest them, and then actually also act on them. And to give you a very first example, I'm changing to my first landing here. And now we just, suppose we are interested, we are living in Munich. This is my hometown, so I picked up that example. Yeah. And we are using public transport. Right? Now, you could just follow the timetables and so, assume that the trains are in time, but often they are not. The operator is kind enough to feed the actual position of the trains. He makes it MV4, that's the name of the operator, they make it available. So what we can do is we can connect to one of their systems and get a whole stream all of a sudden of things, and slowly but surely you see how my browser window is filling up with sensor data. Now that of course is not very This is actually real life data that gets disconnecting again. So as said, I'm connecting to one of their servers. It's a REST endpoint in that case. It's spitting out a lot of JSON data, and I can see how actually data is fed in, and that's the big difference between real-time data and static GIS information. Real-time data that is fed by a sensor, and each event, so to say, represents the state of something at a certain point of time. Right? And it just keeps on going, and you need to digest it, and you need to derive patterns from that. Well, JSON strings are not very sexy, they are not very readable, so we also have a visual representation of that. If I jump to Munich, you all of a sudden can see all the little symbols then this is how it like. Let me refresh that again. There is now an operations dashboard. It's so to say an operational view of on all Lufthansa flights around the world. It's again live server. It's real data that is fed in, and I think the refresher is even a bit slower, not to overload the server, but for the sake of operation at Lufthansa, that is more than sufficient. Now, this demo is a bit more interesting than the other because the other one was read-only. In this case, we start to do something with the sensor data. Let me show you an example. We do see, of course, a lot of planes here in the area of Lufthansa, Frankfurt Airport. We can start to ask each plane, where are you, how fast are you going, what is your height, and things like that, right? So in that case, for example, there's a plane, it's LH456, it's flying at a certain altitude and flying at a certain speed. Now, let's say that is pretty interesting, then I can start to track that. I can just jump to its position, and then I can start to follow that plane. It's a bit more, right? It's one step more. Now keep tracking things. And to bring it even one step further, I can start to work with geofences. I assume that all of you are familiar with geofences. So if I go to Bavaria, then we might have a certain area that is of specific interest. Noise pollution, or pollution in general, safety zones, it could be anything, right? And now what we start to do now is whenever a plane enters that geofence, we mark it and we give other systems information that they need to act upon it. That could be again another dashboard where operators sit and just wait and start to talk to the pilots. Do you need assistance? What are you doing here? Anything going wrong with you? Things like that. So, two first examples of what you can do with live sensor data, both from the area of traffic. Now, if you think about it for a second, then actually the workflow of working with real-time data falls into 3 steps. First step, you need to be able to read the sensors. And believe me, there are hundreds of transport protocols. Sensors speak UDP, they speak TCP, HTTP, WebSockets. They can store their information in files. It could be anything, right? And they, of course, they have their own language, the way they encode their information. That could be a text file, CSV, RSS, we have seen that, Twitter, anything like that. So your first challenge is how to access your sensors and how to read all that information. Then, obviously, the next one is you need to process that data. And process, again, falls into 2 parts. The first thing is you need to filter down. You don't want to get polluted by all the data. Actually, you might also only be interested in planes that are in your geofence, for example. So you want to filter them down. And then you want to, of course, in the last step, act on that. And that would be that in that example here, you have, again, a geofence is a drive-down polygon. So that's a polygon indicates the area from which in you can reach your hospital within 5 minutes. Say you have an emergency arriving, you want to inform your people in the hospital. Yes, in 5 minutes you need to be ready out there having this and that equipment, right? So that is then actually acting on geo events. We do have a product for that, that's not a surprise, and I'm not going to sell you anything, but just to give you the basis of how we work. That product is called GeoEvent Extension for Server, or short GeoEvent Server. And that, surprisingly enough, follows this pattern, 3 steps. What you see here is various data, the sensors, vehicles, whatever we have, something that happens in the middle and something that goes out and again. Input connectors, that are the terms we use for that. processors or geo-event services. And then another type of services that we call output services, output connectors. Let's run through it in a bit more detail. Input connectors, their only task is to connect things, to connect sensors, make data available in your system so that you can work with that. As I already mentioned, we have various transport protocols that we support from standard all of the box, and we also have various languages, so to say. But of course, we cannot cover anything. Very typical things that we encounter on the market are actually a server, of course. We do encounter file, RSS, TCP sockets, UDP, in case it has to be more fast, a bit less robust. REST endpoints, of course, and WebSockets. And then all the various languages, so to say. If that doesn't suffice, then we do work with our partners, which then in turn also develop their own connectors. And that, if that then again does not do what you want, if you have a very specific case, then we will have an SDK in order for you to develop your own connectors. A good example would be Hadoop or Instagram. Now that we have the sensor data in our system, we want to digest, right? And that are the so-called geo-event services. What do they do? Actually, the first thing they do is they connect your input streams with your output. Right? They say, this from here, bring it there. That can be an end-to-end relationship. So you can read any data sources and distribute it on any channel as you like. And whatever you do in between is also completely up to you. You can do filtering, and you can do processing. In order to make it a bit more interesting, I will again show you a short illustration of this. Suppose these are aircraft again. You have their metadata, you know that this is a tourist flight, the other one might be just a transport flight, military crafts. And now you want to boil down, you are the operator of an airport and you want to boil down all the aircrafts that are flying around. You are only interested in those that are military and those that are close by. So you would probably apply two filters, one attributive filter, only that type, and only within a certain area. And what it comes down into is that you actually have three planes that you will have to talk to and you have to do work with. There are really a lot of filters and processes. I don't want to dive into detail here, but just to give you a rough idea, attributes, of course, you can do the typical matching. You can compare this bit of type X, Y, and Z. Is it not of type X, Y, and Z? Does it have a type? Things like that. Then spatial filters. Does this plane or this object or this person or whatever it is, does it enter a geofence? Does it stay for a certain period of time within that geofence? Does it exit that geofence? That are spatial filters again, right? And once you have your subset of once you have your subset of sensor data that is interesting to you, then you probably also need to do something with that. You need to process it. You need to probably enrich the data, get rid of fields that are not meaningful for your use case. You need to reduce fields. You need to geotag things. So you want to tag events that have happened within a certain geofence, for example, things like that. Incidents, not incidents. There's nothing happening. You can also turn it around. If nothing is happening, then there's something wrong. Things like that. So then, of course, the last step is once you have digested your data, you have processed it, you want to make it available again. And then what we offer to you is you, of course, can alert your people. You can send them emails, SMSs, you can instant messages, whatever it is. You can update the map. It's very obvious and we have seen that already. You can refresh it. And then, by the way, there are two ways of doing that. Either you just keep track of the most current position, or you just follow the whole path. You draw the line, right? Which actually, in most cases, come down to a performance issue. You can talk to other business systems. You can log events in the system. This has happened with that person. I don't know why it pops in my mind, but suppose you are working for a security company and you leave your office during daytime, then they want to track that you have left and you can get things like that. Or you want to close down your eating because you have left the building, easier things like that. And of course you also can start talking again to other systems like another GeoMonday processor because you want to actually act on it. You want to fire again other events and build up a whole cascade of things in order to automate it. So that is more or less what you get out of the box. And as already said, you can extend. There's a Java-based SDK. It gives you actually all the freedom to develop anything that you want if we don't deliver it to you. Connectors for your own sensors, connectors for your own output devices, custom processors, and so forth. And now let's jump to another example. In that case, it's from the we are dealing with trucks. And as you might know, trucks need to stop just after a certain while. Truck drivers are allowed to drive for 8 hours.
Maximum 11 months before.
Yeah. So you actually want to start helping these people because truck drivers they need assistance with that, right? They start to drive, but they do not know is there a place available on the next site, or do I have to continue? When does it get risky for me because I will exceed the 8 hours? It sounds pretty simple, but actually it's a real business case that people are working on. So to show you the app, and actually now for the first time see two sensors. The first sensor, that are the green circles, that indicates the truck stops. The bigger they are, the more capacity the truck stop has.